Okay, today we're going to connect the first derivative and the second derivative with the original graph. Okay, so in 5.2 we did first sign charts, and that checked to see if there was max and a min, and it tells you if the original graph is increasing or decreasing. If it goes from positive to negative, there's a max. From negative to positive, there's a min. The second sign chart, which is the double derivative sign chart, checks for inflection points, where it goes from concave up to concave down. If it changes from positive to negative or negative to positive, then there's called a point of inflection, which looks like this. So right here, it went from concave, this is concave down, and this is concave up. So this is concave down, and this is concave up. Okay, so find where the original graph of x cubed minus 12x minus 5, tell me where it's increasing, decreasing, local extremes, concave up, concave down, point of inflection, and also graph it. So the first thing I'm going to do is I'm going to find the mins and the max. 3x squared minus 12. Set that equal to 0. Divide by 3. So at x equals 2 and a negative 2. And then you come over here. This is the interval. This is the derivative. And this is the behavior of the original graph. We're going from a negative infinity to a negative 2, a negative 2 to 2, and 2 to infinity. And what you're going to do is you're going to put in 0, a negative 3, and a positive 3 into the derivative equation. So here's the derivative equation. When I put 0 in, it's negative. When I put a negative 3 in there, the sign is positive. If I put a positive 3 in there, the sign is positive. If I go from a positive to a negative, I know there's a max. If I go from negative to positive, I know there's a min. And this is the graph. The original graph is increasing, the original graph is decreasing, and the original graph is increasing. So I'm going to fill this in right here. It's increasing by looking at my chart from a negative infinity to a negative 2, union with 2 to infinity. It's decreasing from a negative 2 to 2. And I know I have a max at a negative 2, comma, and don't forget to find the y value. And I know there's a min at a positive 2, and don't forget the y value. And you have to go back up into the original and put in 2, which makes 8 minus 24 minus 5. 8 minus 24 is a negative 16, minus 5 is a negative 21. And then you plug a negative 2 in, you get a negative 8 plus 24 minus 5. A negative 8 plus 24 is 16, and 16 take away 5 is 11. So I found my A, my B, and my C. And now I'm going to find the D, the E, and the F now, which is new. So I'm going to do my double derivative sign chart. So double derivative is 6x, set it equal to 0. X is equal to 0. So this chart here, still going to have an interval. This is going to say double derivative, and this is the behavior of f of x. A negative infinity to 0, and 0 to infinity. So you're going to plug in a negative 1 and a positive 1 into the double derivative, and when you plug a negative 1 in, you get a negative. When you plug a positive 1 in, you get a positive. The behavior of the original graph is going to be concave down, and this part's concave up. And there's a point of inflection right here where it goes from negative to positive. So I can fill this in. It's concave up from 0 to infinity, concave down from a negative infinity to 0. And I also have a point of inflection at 0, comma, negative 5. So, what I'm gonna do is I'm gonna draw my graph by all the information that I got. So at 0, -5, I have a point of inflection. At 2, -21, way down here, I have a min. At a -2, 11, I have a max. It's gonna increase from a -infinity to a -2, so it's gonna increase to here. And then it's gonna decrease all the way down to here. And then it's gonna increase back up again. There's a max here. There's a min here, like I said. Here is I went from concave down and it switches to concave up. You see how when you, like this, right here, it goes from concave down to concave up. You see that? So, okay, the next graph. A motion on the line, use the first sign chart. So if they ask you about the motion on a line, you're gonna do a first derivative, 6t squared minus 28t plus 22. And then you're gonna factor this. Oh, let's set it equal to 0. Well, it's probably gonna be 11 and 2. And you're gonna put 3t and 2t, 22 and 6. So these are both gonna be negative. And then t is gonna equal 1 and t is equal to 11/3 when you solve for t. So you're gonna make yourself your first sign chart. This is the interval. This is the derivative, and this is the behavior of f of x. You're gonna go from a -infinity to 1, 1 to 11/3, and then 11/3 to infinity. You're gonna put 0 into the derivative, and you're gonna get a positive. Between 1 and 11/3 is 2, so when I put 2 in there, I'm gonna get 24 minus 28 times 2 is 56. So 24 minus 56 plus 22 ends up being negative. When you plug 3 in there, you get 54 minus I need to plug 3 in there, so let's see what I get when I plug 3 in there. I get 54 minus 28 times 3 is 84 plus 22, and this makes a negative, and this makes a positive. So it's gonna still stay negative, and that's okay that it went positive, negative, negative. So the original graph is increasing, and then it's decreasing, and it's also decreasing. So the motion on the line, instead of, you can have one more layer right here, and this is the motion. It's moving forward, it's moving backwards, and it's also moving backwards. So if they ask about the motion, increasing is forward, decreasing is backwards. Okay, let's look at page 219. We're gonna do problems number 21. So let's look on in the book. Problem number 21 in the book in 5.3. And this is what it looks like. You can skip over these. You do not have to do these problems, but I wanted to go over them with you so that you understand that this, on number 21, is f of x. And you need to estimate where a, f prime of x, and is equal to 0, positive, and negative. So the first derivative is 0, positive, and negative. And then b, the double derivative, is 0, positive, and negative. Okay, so if you think about your sign charts back here, I like referring back to the sign chart. On the original graph, if it's increasing, the derivative is positive. If it's decreasing, the derivative is negative. If it's increasing, the derivative is positive. So keep that in mind. So if the first derivative is positive, it's where the original graph is increasing, it's where it's decreasing. So it's increasing to a negative infinity to a negative 1, union with, it's also increasing from 1 to infinity. It's decreasing from a negative 1 to a positive 1. Where does the derivative equal 0? The derivative is equal to 0, or the slope equals 0 at x equals a negative 1 and x equals a positive 1. Okay, it's the same thing for the double derivative. The double derivative is, if it's positive, let's go back to the double sign chart on here. The double sign chart says if it's negative, the graph needs to be concave down, and if it's positive, it needs to be concave up, and when you switch, there's a point of inflection. So we go back to this one. So, right here, it goes from concave down to concave up. So there's a point of inflection at x equals 0. And it's positive. Concave up is when it's positive, so 0 to infinity and a negative infinity to 0. So that's number 21, reading an original graph. Okay, now we're going to do problem 23. We are gonna, it's gonna come down at 2, negative 2, and then it's gonna come back up through 0, and then go back down. Whoops, what happened there? We'll be right there. I don't know what happened, but we'll get you back here. There we are. Okay, so this is problem 23, and this is not f of x. This is the derivative graph. And if you read the directions for 23, they want where the original graph, they want to know where the original graph is increasing for A. They want to know where the original graph is decreasing. And they want to know if there's any extreme values, or is there a max, is there a min. So this is the derivative graph. So this is what I like doing. If this is the derivative graph, these are all positive slopes. This is where the original graph is increasing if you think of your the formula. So from a negative infinity to a negative 2, union with 0 to 2. It's decreasing on those other intervals. So a negative 2 to 0 and 2 to infinity. Okay, I'm going to make this a different color. This is where it decreases because it's below the x-axis and below the x-axis. Now comes the next part, the blue. Notice it went from a positive to a negative. If you go from a positive to a negative, you must have a max. You can't say the point because it's the derivative, but there is a max at x equals negative 2. And if you go from a negative to a positive, you know you have a min at 0. And you also go from a positive to a negative right here, so you know you also have a max at a positive 2. So that's how you do 23. And then the last part is let's do 50 together so you have an idea on how to read one like this. Here's number 50. Okay, so this is a derivative graph. It's really important that you understand that it's a derivative graph or an original graph. And if you look at problem number 50 at 1, 2, and 3, and then it goes up 1, 2, 3, 4, 5, this is closed. And it goes all the way up to here and stops. And then it comes down and makes an open circle. And then at 2, there's an open circle to a closed circle. So we're going to go through A, where is the original graph increasing? B, where is the original graph decreasing? And C, is there any maximums or minimums? So you have to check all these. Okay, remember that this is a derivative graph, so all of these are above the x-axis. So it's increasing from 0 to 3. There is none for B. It's none of it's below the x-axis. And then you have to check your endpoints. If it's the derivative graph, if left is less, then you have a maximum. If left is more, you have a minimum. And then you keep going. If right is more, you have a maximum. And if right is less, you have a minimum. So if you look at the left is more, so you have a minimum on the left side, and you have a minimum at 0. So you have a minimum at 0, and you have a maximum because the right is more, so you have a maximum at x equals 3. So don't forget, left is less, there's the max, and then you fill the rest in, but you always have to check the endpoints for min and max, so that's also very important. Okay, the next template. We can discover almost everything about f of x by examining f prime of x and f double prime of x. This is just a review. We can find where f of x increases and decreases. We can figure out the concavity of f of x. We can find the max and the mins. We can find the point of inflections, and we can figure out the shape. But this is what we don't know. We don't know how to place it on an XY graph. We just don't know where to put it. And that's why anything, you can put it on there and it's acceptable, because we just don't know where to put it on the graph. We know, like right here, maybe the sign chart, I'll give you a sign chart like this, from a negative infinity to 2 is positive, and this is the derivative, and this is the behavior. We know that it's increasing to 2, so this is just to show you, if it's increasing to 2, a negative 2, sorry, increasing from a negative infinity to a negative 2, well, we know it's increasing to here. So we have to increase it to here. Does it look like that? Do we put it like that? We just know that it's increasing to 2. Do you understand that? We just don't know where to place it on the map, on the graph, so anything would go. And then we know that it's decreasing, so then you have to make a decrease, and so on. We just don't know where to place it. So that's important to know that. And now the last part. A function f of x is continuous from a negative 2 to 4. So let's look at this. From a negative 2 to 4, it's continuous. You're supposed to find all the absolute extreme values, you're supposed to find the point of inflection, and you're also supposed to graph this. So let's try to read this chart. Okay, first of all, the first derivative, from a -2 to 0, it means it's positive. That means the original graph is increasing. The double derivative, if it's positive, means that it's concave up right there. At x equals 0, the derivatives do not exist, so there must be a corner, an open circle there. From 0 to 2, it's got to be decreasing, and it's also concave up. And at x equals 2, the slopes are zeros, which means that there's a horizontal asymptote. And then it's also decreasing here, and it's a concave down. So what I'm going to do first is to graph this. So at -2 to 0, and then 0 to 2, and then to 4. So I'm just going to put that up there. So from 0 to 2, I know my graph is increasing, and I know it's concave up. So I know it's increasing to a -2, and I know that it's concave up. So so far, that's good. So I'm done with that. At x equals 0, oh, it needs to keep going concave up to there. -2, 0, it's increasing and it's concave up. At x equals 0, the derivative does not exist, and the double derivative does not exist. So at 0, I'm going to make a corner. From 0 to 2, it's decreasing. So it's a cusp. I made a cusp. From 0 to 2, it's decreasing. It's definitely, it's still concave up. And at x equals 2, it's going to, at x equals 2, it's going to decrease, and it can look like that. So from 2 to 4, it's not the best, but it's decreasing. It's definitely concave up. It's increasing, or it's decreasing, and it's also concave up. So this is the graph that I would use to do this problem. Oh, I didn't see this, but this is how you would place your graph on there. When x is 4, so at a -2, it's a -5. So I would have to redo this because I would have to place it on the map a little bit different. At a -2, it's 5. So let me start again, placing it on here better. At a -2, it's 5. And at 4, it ends with a 1. So that kind of lets you know how to place it. So it increases to 0, and then it goes like this and like that. So I just have to place it up on my graph a little bit higher. So, okay, these are all the notes for 5.3.